Hello, today I am going to share with you how to solve instrument output signal based on direct linear equation that I have created in my previous video. So let me draw a simple picture here. Okay, let's say I have a transmitter here. Okay, this is my temperature transmitter. Alright, they measure the temperature in a pipeline. Okay, this temperature have a instrument range of 50 Fahrenheit to 140 Fahrenheit, and the output signal range is 4 milliamp to 20 milliamp. All right, so let's say I want to find if the temperature transmitter reading is 79 Fahrenheit. So what will be the corresponding milliampere signal that will be sent to the PLC? We can put the 4 to 20 milliamp as our X value. Okay, for example, the Xn will be 4 milliamp. Okay, and the XX, which is the maximum X, is 20 milliampere. Okay, while for the Yn or minimum Y or the LRV is 50 Fahrenheit, and the Yx or maximum Y or the URV upper range value is 140 F. Okay, and we can treat this one as Y1 79 F. Okay, 79 F. So what will be the corresponding milliamp given 79 Fahrenheit temperature reading? Okay, so what will be the corresponding milliampere? So how do we find? So based on these two linear equation or direct linear equation that we have created just now, we can make use of this equation to find our output signal and vice versa. Meaning we not only can use this equation and this equation to find the milliampere signal, but we also can find the corresponding instrument reading based on the milliamp signal given. So it is a very versatile and flexible equation. Okay, so before we do that, we need to find the M value, which is a slope value, and the C offset value. So how do we find? Let's say M is slope, which is a y1, sorry, which is a yx minus yn, xn minus xn here. So yx is this one, 140 minus yn, 50. Okay, divided by xx, which is 20 milliampere, minus what xn, this one, minimum x, 4 milliampere. So the reading will be 5.63 for this from equation 1. Okay, yn equal to 5.63, which is this one. Okay, then multiply xn plus c. So we know that yn is this one, then xn is this one, so we can plug in the value. So yn is 50 5.63 xn is this one 4 milliamp plus C. So C will be equal to 27.48. Okay, then we write the equation from equation 1, yn equal to 5.63 xn plus C 27.48. Okay, so this is our new equation. Okay, our new equation 1a. As we know that this yn and xn is here, yn and xn, which is the same that you substitute with y1 x1 or yx xx or any value of y and x, right? So can be this equation 1a can be rewritten as y equal to 5.63 x plus 27.48. Okay, this is a new equation 1b. So since x1 is since we want to find x1 given y1 is 79, so we can plug in the value. Okay, 79 equal to 5.63 x plus 27.48. So x will be, so the value will be about 9.16 milliampere. This is the answer. If I want to use a second equation, is it possible? Yes, of course, it is possible. So how do we do that? Let's say from the second equation, okay, y1 equal to m, the slope. As we know, the slope value is a 5.63. So 5.63 x1 minus xn plus yn. So this xn is this value. Okay, 4 milliamp. So we put 4 plus yn is 50F, so 50 Fahrenheit 50. So this will be our new equation. As we know, y1 x1 is here, y1 to x1 is equal to yx to xx and so on. So we can rewrite the equation as y equal to 5.63 x minus 4 plus 50. So this will be our new equation. Given the y1 is 79 Fahrenheit, so what is the value for x1? Milliampere. So we can plug in the value into the y. 79, 5.63, okay, x minus 4 plus 50. So x will be equal to 9.16 milliampere. So for this instrument, there has a instrument range of 50 Fahrenheit to 140 Fahrenheit, and the output signal range of 4 milliampere to 20 milliampere. If the temperature transmitter reads the temperature reading of 79 Fahrenheit, the corresponding milliampere signal that will be sent to the PLC is 9.16 milliampere. So that's it. Thank you.